All right, so today we're going to look at sum and difference identities. So the first thing I want you to do, take your formula sheet out and see if you can find these sum and difference identities. We're mainly just going to work with the sine and cosine sum and difference identities. We won't worry too much about the tan ones for right now because they're quite a bit trickier. All right, so before we start that though, I do want to do a quick review question on non-permissible values. So this is another example for a diploma. I'm going to go through the question. However, if you'd like to try it by yourself and then see if you did it right, you could pause the video right now. Okay, so let's start. 1 minus sine squared theta. So I'm looking for non-permissible values. So here, I know sine squared theta can't equal 0. So I'm just going to write sine theta can't equal 0. Over here, I know cosine squared theta can't equal 1. Positive or negative 1. Okay, so that means cos theta can't equal 1. Cos theta also can't equal negative 1. So if you take your unit circle out, and again, I'm just going to draw part of it. Your coordinates here would be 1, 0. That would be at 2 pi or 0. Your coordinate over here would be 0, 1, which would be at an angle of pi over 2. Your coordinate over here would be negative 1, 0, which would be an angle of pi. And your coordinate down here would be 0, negative 1, which would be an angle of 3 pi over 2. All right, so that's just kind of a rough draft of my unit circle. So now I know sine theta can't equal 0. So all my coordinates are listed as cos theta, sine theta. So where does sine theta equal 0? At 0 and 2 pi and at pi. So every pi units. So I'm going to go pi n where n can't equal any integer. Where does cosine theta equal 1 and negative 1? Actually the exact same place. Pi, 2 pi. So then that means this would already include where cosine is 1 and negative 1. So I don't need to write an additional statement. So this would be the general solution for my non-permissible values. So that means A would be the correct answer. All right, so let's get started on sum and difference identities. So let's start here. So we know sine 60 plus 30 equals, so 60 plus 30 is 90 degrees. So on your unit circle, okay, what does sine 90 degree equal? It equals 1, right? Okay, so now I'm just going to be referring to my unit circle. So take your unit circle out if you have it in front of you. So sine 60 degrees, sine equals root 3 over 2. So I'm replacing this trig angle with the ratio, root 3 over 2. So notice how I don't write sine anymore, right? Because sine 60 degrees equals root 3 over 2. So I'm replacing that whole sine 60 degrees with its equivalent ratio. Cos 30 degrees also equals root 3 over 2. And again, this is coming straight from your unit circle. Cos 60 degrees equals 1/2. Sine 30 degrees equals 1/2. Okay, so now let's go ahead and simplify the right side here. Root 3 times root 3 is 3. Right, because those square roots cancel out. 2 times 2 is 4, plus 1 times 1 is 1, 2 times 2 is 4. So I have 3 over 4 plus 1 over 4 gives me 4 over 4, which is just 1. So I've shown that the left side equals the right side. I've verified this equation. Left side equals right side. Okay, let's try the subtraction one this time. So pi over 3 minus pi over 6 is pi over 2. Or wait, let's actually try that out. What is pi over 3 minus pi over 6? 1 over 3 minus 1 over 6. Oh, it's pi over 6. So that gives me pi over 6. So on my unit circle, what is the ratio when sine is equal to pi over 6? 1/2. And now I'm just going to use my unit circle to fill in these ratios. So I'll skip ahead. Sine pi over 3, my ratio equivalent to sine pi over 3 is root 3 over 2. Cos pi over 6, the ratio is root 3 over 2. Cos pi over 3, the ratio is 1/2. Sine pi over 6, the ratio is 1/2. Okay. So let's simplify that. Root 3 times root 3 is 3 over 4 minus 1 over 4. So 3 over 4 minus 1 over 4 is 2 over 4, which is the same as 1/2. So the left side and the right side both equal 1/2. So I've verified that that is true. Okay, so actually this is a very difficult example. There's lots of rationalization, so we won't go through this. However, if you wanted a special extra challenge, you could try it, and then all of the answer with all the steps is on the completed notes on Moodle. But there is quite a bit of algebra and rationalization involved, so we will skip that for right now. Okay, and then on the right, we're not going to do this one, and we're going to just do the one on the left. So sine 100 degrees cos 10 degrees minus cos 100 times sine 10. So we're looking on our formula sheet where you have sine A, so A would be my first angle, cos B, B would be my second angle, minus cos A, sine B. So where do you see this? Okay, which identity is that equivalent to? So if I look at my unit circle, I know that it's identical to sine A minus B. So that is the same as sine A minus B. So now that I know that and I'm using my formula sheet, let's substitute the angles in. So we know A is our first angle, which is 100 degrees. B is our second angle, which is 10 degrees. 100 minus 10, of course, is 90 degrees. And we could even simplify this further. So if we go to our unit circle, sine 90 degrees equals, what does it equal? It equals 1. Excellent. Okay, this next question, this one's pretty important. I definitely will be putting one of these on your weekly quiz, 1 or 2 probably. Okay, so let's start off by drawing our angles. So cos A equals 3 over 5. So you have 2 different angles. So I'm going to actually draw 2 different pictures, one for each angle. So let's draw a picture for angle A. Let's draw a picture for angle B. So it says angle A is between 0 and pi over 2. So I know angle A is in quadrant 1. Okay. And let's figure out what else we know about angle A. We know for angle A, cos A equals 3 over 4. So let's fill in some of our drawing here. So cos is, of course, adjacent over hypotenuse. So I can fill that in. All right, now let's draw angle B. Angle B, and let's use a different color, like green. Angle B is between 3 pi over 2 and 2 pi. So that means angle B has to be in quadrant 4. So it has to be down here. Okay, and then we can write what we know for angle B. So we know angle B, cos B equals 5 over 13. So adjacent over hypotenuse. So now I've written this out, and they also give me this identity. So whenever you're given an identity, go to your formula sheet and let's write that identity out. So we know cos A plus B equals cos A. Oh dear, that was pretty messy writing. Let me fix that. Is it gonna let me erase it? Let me erase this. There we go. So we have cos A, cos B, minus sine A, sine B. So again, those are my angles, and I can fill in the ratios, right? So that's what I'm doing here. So I already know cos A equals 3 over 5, so I can replace cos A with 3 over 5. I know cos B equals 5 over 13, so I can replace cos B with 5 over 13. But I don't know what sine A equals, so I'm going to go back to this picture I drew and figure it out. So I'll have to use Pythagorean's theorem. 5 squared minus 3 squared is going to give me 16. So I know my y value here would be 4. So then that means sine A equals 4, opposite over hypotenuse, so it's going to equal 4 over 5. So now I can replace that sine A with 4 over 5. Okay, sine B. So now I'm going to go to my second picture down here. And I'll have to use Pythagorean's theorem again to figure out what that y value is. 13 squared minus 5 squared. If I type that in my calculator, I should get 12. Because we're in quadrant 4 here though, it should be a negative 12, so make sure you don't forget about your signs. Okay, so then sine b equals opposite, which is negative 12, over hypotenuse, which is 13. So now I have the ratio for that one, so I can replace sine b with that ratio, negative 12 over 13. Now from here, I can just simplify. Type it in your calculator, right? So on my calculator, and let's try and see if my calculator will do this. Okay, and because you're just typing ratios in, you don't even need to be in degree or radian mode. It doesn't matter because all you're doing is typing the ratios in. All right, so we're gonna go 3 over 5 times 5 over 13 minus 4 over 5 times negative 12 over 13. Perfect. Okay, and then to get the fraction, math fraction, enter. 63 over 65, because it wants an exact value, so I can't write the decimal. I need to write 63 over 65. So cos A plus B equals 63 over 65. So that would be, oh, I wrote 63 again. Whoops. So that would be my final answer. Okay, and try a couple of the questions. Again, look at the solutions online. Don't worry about any that have too many steps, and we will talk to you again soon.